Hi, welcome to my channel. Today in this video, we are going to talk about the next inheritance strategy in our list, which is table per class. In our last video, we saw single table strategy where every class in the class hierarchy was sharing the same database table. We put all commonly required columns in the parent class, and every child has its own set of attributes and it is responsible to update the data of those fields. Along with these fields, we have one extra column in our table which is managed by JPA. JPA stores an identification value in this field to determine the owner of that particular record. We use discriminator column annotation to tell JPA that which column in table it can use to store an identification value. Now let's come to today's topic, which is table per class inheritance. In this strategy, we use table per class inheritance type. And unlike single table, in this strategy, every class in the class hierarchy has its own independent table in the database. We put all columns in parent class, which is commonly required by child classes. And every child class has its own set of attributes as well. The major drawback of this strategy is the polymorphic query generated by Hibernate in this case is really complex. Like in this example, if we query the parent class to fetch all records from the childs as well, Hibernate generates query to fetch records from the individual entity in the tree, and then uses union keyword to merge results. But if you want to query a child class directly, then the query generated by Hibernate is quite simple. It is like querying data from a single table. Now let's go to our code editor and implement this strategy. I haven't created any tables for this tutorial. What I'm going to do is, instead of creating tables manually, I'm going to define our entities first and let the Hibernate read those entities definition and generate all required tables automatically for us. Okay, so let's create our first entity, which is vehicle.java. At entity, at inheritance, strategy inheritance type dot table per class. Now let's define some common attributes that we require in child class also. Private int id, string model name, private string model, private string fuel type, private string mileage, and classification. Okay, and here this is our primary key field and it is going to be generated automatically, so annotate it with id and generated value strategy generation type dot sequence. Here we cannot use generation type identity because table per class inheritance does not support it. So here either we can use table or we can use sequence. Now let's generate getters and setters. Okay, now save this. Now let's create our child entities, and I'm going to create a new folder inside entities, vehicle, and here our first child is car.java. Annotate it with entity extends vehicle class, right? And let's suppose this class has two attributes, seating capacity and sunroof. Right click, getters and setters, save this. Now the second child, which is motorbike.java. Extends vehicle, and let's say this class has pylon seat and passenger footrest, and let's say saddle height. Right click, again getters and setters. Okay, Now here I'm going to cover one more topic, which is how we can use these inheritance strategies when we have some sort of associations between entities. And for that, I'm going to create one more entity here. Let's say manufacturer at entity, and this class has two fields. One is ID and second one is name. Okay, now this one is our primary key, so should be auto generated strategy generation type, and here we can use identity, right? Now the idea is to map our manufacturer with vehicles. The association between manufacturer and car is one to many. One manufacturer can manufacture multiple vehicles, so it should be list of vehicle, or you can use set of vehicle, right? Annotate this attribute with at one to many, and at join column name equal to manufacturer ID. This field is going to be our foreign key in vehicle, car and motorbike table, right? Now let's generate our getters and setters. Okay, save this. Similarly, go to vehicle.java. Here we need to define the association between vehicles and manufacturer. As I said, a vehicle can have one manufacturer, or many vehicles can have one manufacturer. So here the association should be many to one. So at many to one, at join column name equal to manufacturer ID, insert table false and update table false, private manufacturer, right? Save this and let's generate getters and setters for this. Okay, and annotate this property with also JSON ignore. Okay, now if you want to know more about these associations and this JSON ignore annotation, I recommend you to watch my earlier videos in this series. Now let's create repositories for these entities. Inside repositories folder, let's say manufacturer repository.java, should be interface, right? And at repository extends JPA repository, and should be type of manufacturer and integer, right? Save this, create one more for vehicle, interface at repository extends JPA repository, type of vehicle and integer, car repository interface extends JPA repository, type of car and integer. Now the last one, motorbike repository motorbike and integer. Now in this tutorial, instead of creating a separate service class to use these repositories, what I'm going to do is I'm going to auto-wire all these repositories in controller class itself. And if you are new to my channel and you want to know how we can create a service class to access these repositories, I recommend you to watch my previous video in this series. So let's create our controller class. Vehicle controller.java, add fresh controller, add request mapping vehicle. Now here let's auto-wire our repositories. Okay, manufacturer repository, vehicle repository, car repository, and motorbike repository. Now let's create some endpoints to insert records using these repositories. So the first one is our post mapping. Let's say add manufacturers, public list of manufacturer, add manufacturers, and in request body we are going to pass the list of manufacturer. Simply return manufacturer repository.save all manufacturers. Okay. Similarly, let's create few more endpoints. This is for vehicles. Okay. Copy, paste and paste. This one is for add cars. Car repository.save all, and we are going to pass cars here. Change this to car and cars. Okay. Now change this one to add motorbikes. Motorbike repository dot save all. Okay, now save this, run the application. Now if you check the console, you can see that Hibernate has generated all required tables for us. Okay, so let's go to our database and check what it has done. We got car, motorbike, manufacturer and vehicle, and that too with all required constraints, right? And to maintain the sequencing, it has also generated the Hibernate sequence. Okay, now let's go to Postman and hit this endpoint. I have already created this request with all required data, right? So let's hit send. We got status 200. Go to database and check the data in manufacturer. Okay, now similarly let's hit this endpoint, add cars. Okay, hit send. We are getting status 200. Go to car, check the data, and here in manufacturer ID we do not have the manufacturer ID that we were passing here, because we do not have any property in our entity class to set this value. So let's create this property in our vehicle.java. Private int manufacturer ID, right? Source action, getters and setters. Save this, kill the terminal, run it again. Let's delete these records. And hit this endpoint. Status is 200, right? Refresh this. And this time we got manufacturer IDs as well. Okay. Now similarly, let's hit this endpoint to add motorbikes. Send. Check the data. Okay. Now let's add one vehicle. Right? in this strategy, the insertion method is similar to what we have seen in single table strategy. Now let's see how to fetch these records from the database. Go back to Visual Studio Code, and in vehiclecontroller.java, let's add some endpoints. Get mapping, get vehicles, public list of vehicle. We are not going to pass anything, simply return vehicle repository dot find all. Okay, let's create one more endpoint, get mapping, and this time get cars, public list of car, get cars, not going to pass anything, return car repository dot find all. Get mapping, get motorbikes, list of motorbike, get motorbikes, return motorbike repository dot find all. Okay, and the last, get mapping, get manufacturers, list of manufacturer, get manufacturers, return manufacturer repository dot find all. Save this, run the application. Let's create request, get mapping, copy this link from here, paste it here. We are going to hit this endpoint first, get vehicles, send. Now we got all record in vehicle table, car and motorbike table. Okay, now let's see what query Hibernate has generated. Now, as I shown in the PPT presentation earlier, Hibernate has generated a complex query to fetch all records, okay, using this union keyword. Now let's hit other endpoints as well. Okay, I made a typo here, but it really doesn't matter. Let's hit this endpoint. We got all records what we have in our car table, right? And this is the query generated by Hibernate. It is simply selecting all records from the car table. Okay, let's hit this endpoint, get motorbikes. We are getting all records which is in our motorbike table. Okay, now let's hit this endpoint, get manufacturers. Okay, this time with manufacturer we are also getting all child entities, and the query which is generated in this scenario is much more complex. Okay, let me show you. This is from here to all over here. Okay, I usually avoid this inheritance strategy because it adds complexity to queries, and when we have multiple associations between entities, this will get much more complex. So use this strategy when it is really required. So this is it for this video. If you like this video, please hit that like button and subscribe to my channel. And in next video, we are going to see the next inheritance strategy in the list. Until then, bye bye and take care.